Right? This is from Kyoko. Okay, Kyoko. Okay, I can see Noah's camera also. So as per usual, look at the Jamboard. Okay. I'll wait for your camera to be ready, Noah. Okay, good. Now, can I confirm both of you are in the new Jamboard, page 1? I have a lot of laser pointer here, and I have a few things in page 1 of the Jamboard. Are you there?
Yes.
Okay. Now, Noah, this will seem familiar to you. You'll be needing it anyway. So, Kyoko, your secretary, just want to revise with you. This is the table, right? Right. It will be available for us to use. However, sometimes some question will require it and sometimes not. It will depend on the question itself. So it's just ready for us, right? Same thing with the formula. Sometimes we will use it and the question will not warn us. We are the one that is supposed to know. And that's what we are learning today. Like, oh, this question wants this. Oh, this question wants that, right? The graph is the same thing. This graph, the basic sine, cosine, and tangent graph will be available to us, but we need to use it depending on what the question asks. These are all the basics. Yeah. Now for you, Noah, you will notice that you know this already. And you will notice that this formula is what you call identities. And the identities list is not complete. My question to you is, Noah, do you have a complete list of identity for yourself to use? Do you
What's
have
the
it?
complete one?
The one which has 9 identities, which is given in exams or prelims usually. Do you have it with you? All right. You can remember them. I don't mind. But the point is you should have it available for you, right? In case you need it later. All right. So I will treat you that you can find them. But if you forget, please, you can just ask me so that you don't waste time remembering things. Okay, Noah?
Okay.
Can you? Right. Okay. So we're moving on to page 2. If there is no question, yeah. Okay. So page 2. Yeah. Observe page 2. I'll explain a little bit to Kyoko first. Yeah. Yeah. If you know how to do this, you can just do it. Sorry, I forgot to say. No, if you remember, you just do it lah. I'll explain with Kyoko and then I'll go and do it. Yeah. Now, Kyoko, remember I say AMAT is obsessed with nice numbers, correct? Yeah.
Yeah.
Now, let me give you an example. If the question asks you for sine 30, what this means is that, sine 60, for example, what this means is that they kind of say to you, cannot calculate, correct or not? Because of the table, you must remember that this is the answer. Can you?
Mm.
Now, let me show you what happens here. This is another form of their obsession. Right, so now tangent A, yeah, tangent A is equals to minus 3/4. This is for example. Do you notice that the question mark has switched side, Kyoko? The question mark is now here, the angle, instead of the result. Correct or not?
Mm.
Right.
Yes.
Now they never say this. But in this situation, they also forbid you basically from using calculator. Now, this is a new kind of, but their motivation is the same. Now, I want to explain why we must think that way. So, Kyoko, you go and press your calculator first, because you're supposed to be able to find A using your calculator, but they forbid, but you still can do that. Give it a try. Very ugly number. Okay. Now I'm just going to say that, I'm just going to write it down first. The answer is an ugly number minus 36.9 degree lah. Okay, roughly right. Okay, yeah. Now, nothing in the question tells you you cannot use calculator. However, if you do that, you will certainly lose the marks. I'm not sure whether you lose one or you lose all. How do I know? Very simple. Because they ask you second A. Now, you do notice that they never ask you to find A, right? They never ask you to do that. They just ask you to find second A, right? Whatever second A is, I forgot to tell you, this is 1 over cosine A. It's just that simple. Now, why am I very sure that you cannot just press the calculator? Because you try now pressing the calculator 1 over cosine A, right? That means the A will be the result that you get just now. You give it a try. Right? All right. So, what is that? What is the result of 1 over cosine this? Yeah, I cannot see. I cannot see the answer. Okay, let's say, oh, they actually give you a nice, oh, your calculator is not there. Right, okay, 5. Now, from the calculator. So actually, surprisingly, the calculator gives you a nice number, right? Surprisingly. This doesn't always happen, but this sometimes happens. For example, in this situation, the other one, the B later, you will probably not get a nice number. So we'll call this a lucky nice number. We just call it a lucky nice number. Now, the question never say, but they really want a nice number. They really want it. So you give him through calculator, and then the question will say, very surprisingly, I cannot accept your answer. It is very weird. Let me remind you, this is very weird. They want to see you do another way and not the calculator way. This is basically the insistence or the insistence of the question, right? Now, to show you that this is a lucky number first, I'm going to show you. I'm going to ask you to do it with B, right? For example, this sine A plus B, right? For the first one, you realize that we need formula here, right? Correct? Correct, yeah. Remember the formula from page 1, right? The first formula, the sine A plus B. Refer to the first page, the first formula. All right, so read for me the first formula.
Sine A plus B equals to SACB.
Correct.
Plus.
So it's sine A cosine B, right? Yeah, plus cosine A sine B. Now, so you go back to page 2. I just put the formula for our use, right? Now, very clearly, I will need this guy, I will need this guy also, correct? Right.
Jumbo is lagging.
Jumbo. Okay, page 2, yeah. Okay.
Yeah.
So cosine B is given in the question, 15 over 17. So that's not a problem, correct? It's not a problem. But I must find sine B. Now, what can I do? Well, for example, I can use the calculator, even though I explicitly say to you, oh, this question will not accept what. But I mean, you can if you want to try. So what do you do if you use calculator to find sine B? What would you do? Sorry, you're saying? Sorry?
What do I do?
Oh, what do you do? Oh, okay, Ainesh. Oh, now, okay, so now I see you, Ainesh. Good. Okay, I was explaining to Kyoko, yeah, so might as well. We have already started, Ainesh, so you gotta feel weird a little bit because you missed the first few parts. Yeah? So Ainesh, take your calculator and put your video on, so I can follow you quickly.
Okay.
I'll wait for it. Noah, are you stuck so far? You look good, but are you stuck?
I'm stuck.
Very good. Very good. Yeah, I see that your first answer is correct. So I like it a lot. Good. Okay. So Kyoko will wait for a while. Feel free to do it by yourself. I mean, you don't have to wait for that. But I'm gonna wait for Ainesh to explain. Okay, Ainesh, is it okay, the calculator and the video? Okay, very good, Ainesh. Okay. All right, so you have your calculator? So, Kyoko, I'm going to spell out the steps for the benefit of Ainesh, but I hope you understand what I'm doing. Yeah? So, Ainesh, we are currently discussing this. The question gives us cosine B, a reasonably nice number, right? In Jamboard page 2. Are you following Jamboard page 2?
Yeah.
All right. So, the question gives us cosine B, a reasonably nice number. The question requires from us sine B because of this formula. Okay, yeah. So I was telling Kyoko, there is a forbidden way of doing it. The forbidden way will not be correct precisely also, but you can do that. You can do that by using calculator. Sorry. So please press your calculator, both of you.
One second. This is the formula.
Yes, this is the formula that you missed out, and I just list down in the first page so that you know that it is there for us to use. I won't explain the origin of the formula, but it is there given even in normal exams, I suppose. Normal schools exam, it's given one. We just have to know that it is there to use it. Understand, yeah? Right? We just have to know that it is there, and then we are to use them. Okay, Ainesh? Can? Yeah. Okay, now press your calculator, both of you, Kyoko and Ainesh. We're trying to find B. Now, what would be the answer? Okay, the answer is not something very nice. So I'm going to put it down as 28.01, right?
Yeah.
Now, Kyoko and Aditya, Ainesh, you're not pressing the calculator. Come on, quickly.
Yeah.
Very good. So use that answer inside the sign. You're going to preserve the answer, right? So you're going to press sign bracket answer lah. Okay, so that you preserve the answer inside the sign. Please do that. Sign answer, and then do you have a nice number, right? Okay, then press equal.
Okay.
I think you are you in radian mode, Ainesh? Are you in radian mode?
No,
Okay, degree mode. Okay, 8/17. It should be 8/17. Good. Now, using the calculator, you get a very nice answer, 8/17. This is relatively nice, right? Nice from the calculator. Now, yeah. I'm in the process of explaining to now both of you, Kyoko and Ainesh, why the calculator will not give you marks. Okay, I'm in the process of explaining why the calculator will not give you marks, even though the calculator is giving you a nice number. Nice number is part of the requirement of this question. It is. They are obsessed by it. But the calculator also basically makes a mistake. The calculator is inadequate. I'm in the process of explaining that this is wrong. And this is also wrong. Now pay attention, right? Now, in the question, they tell us that A is an obtuse angle, right? Or do you know what obtuse mean, Ainesh and Kyoko?
It's more than 90 degrees.
All right. Now be very clear, Kyoko. You are correct lah. It's more than 90, but actually it's more like from 90 to 180. So there's a limit to obtuse angle. Okay. right? Now, quadrant-wise, Ines will call this quadrant 2. What do I mean by quadrant? Because 90 degree, and then another 90. So here's your quadrant 1 is your quadrant 2. Quadrant 2 is just basically from 90 to 180. They also call it obtuse, right? Ines and Kyoko, clear?
Yeah.
Yep.
All right, now this is quadrant 2, right? This will be very important later on. Now, there's also another term that the question used. I haven't explained to you. So do you know what's a reflex angle? Now, Noah, I see that you have the answer, yeah? Let me zoom in a bit for me. Zoom in a bit for me. Okay, nice. The sine A is positive, good. The cosine B, oh yeah, cosine B is positive. Your sine B, I think your sine B have a problem. I think. Are you sure your sine B is positive? Are you sure about that? Are you sure or not? Yeah, you make a mistake there, Noah. Yeah? No, that's not good. You lose 1 mark. I'm not sure 1 mark. I hope it's only 1 mark. Be careful, Noah. Because of that. And then you can move on to page 3. Okay. So back to you, Sec 3 student. Now, reflex angle. Anybody knows what that means?
180 plus.
You're absolutely correct. So it means from 180. In this case, let's limit ourselves to 360.
Yeah.
In terms of quadrant, it will be quadrant 3 and quadrant 4. Let me explain what it means later. All right. So what does the calculator give us? The calculator is not trying to mislead you, but the calculator is giving you something not like that. Okay. When you inverse the B, he gives you, well, an angle which is not from 180 to 360. Correct? He does not. The A is the same thing. We inverse, and then the calculator gives us from 90 to 180. Supposed to be, but he does not do that. He gives something weird number, a minus. This is the problem with the calculator. That's why the question doesn't even have to tell you, don't use calculator. Don't use calculator. The question doesn't tell you. If you use it, you will be wrong automatically, so to speak. Okay, now this is the new thing today, and let's try to find out what it is. Okay, good, Noah. You found your mistake. Be careful with that mistake, yeah? Okay, you move on to page 3. Okay, now I will again try to draw for you this thing. Now, Kyoko, what kind of graph am I doing with my preparation? What am I drawing here?
Sine graph.
Very good. Now, Anesh, in case you don't know, this is a sine graph.
What does that mean?
A graph, which is the result of something like this. So the y will be the sine x, and the x will be the degree. So let me give you an example. This is 90 degree. This is 360 degree. I should have started from there. This is 180. This is 90, and therefore this is 270. Right? This is 1. This is minus 1. If you press your calculator, or if you refer to the table yesterday, sine 90 is 1. Remember, Ainesh? That's what you did yesterday.
Yeah.
Sine 0 is 0, and everything else there's an in between. Look, sine 30 is half, sine something like that. So this represents your table yesterday. Yeah. Kind of. Then if you continue with your calculator, like sine 91, sine 92, sine 93, you will get this kind of decreasing value, and then you go to minus, and then you go up again. This is the result of plotting all the values from the calculator or using your GC. Understand, Ainesh? Yeah. So this is the form that it takes, and it is very important to remember this. The second thing that you want to know that it is actually infinite. So it just continue like that one. It just continue like that. It also continues backward. That's the nature of all trigonometry graphs, right? And yeah. Now, I'm going to draw the cosine graph. Now, Kyoko, is my preparation correct? Is my preparation correct for the cosine graph?
No.
What is wrong? Tell me. Which one is wrong for preparation-wise?
Should be here.
Very good. Very good. Right. So that means, Kyoko, you know the shape of the cosine graph reasonably well, such that you know, hey, I'm preparing something wrong. My preparation is supposed to help me draw, but I'm not doing that just now. I'm doing it wrong. So now you have corrected me. Very good. It's like that. So as you can tell, Inesh, the cosine graph looks kind of similar, but also different from the sine graph. Let's just put it that way, right? It will also continue indefinitely beyond, and then it will also go back. It will do just like that, right? And so go back. We focus on the one from 0 to 360. Right now, I would like to explain why. First of all, B first. Look at cosine. Cosine 28.1. Inesh, please find for me 28.1 in the graph. What is 28.1 degree?
I don't know, maybe like here.
Give me a rough one. Okay, that's in the middle, so that's 45 more likely. So be a bit more accurate. 28.1 is probably more towards.
You see it?
I'm waiting for it. Where is the laser point? This is super slow. Okay, let's not wait for it too much. All right, so 28.1, it's not in the middle, but it's probably more towards the left. So maybe we'll say this is 28.1 degree. Can something like that make sense? Can you see it?
Yeah.
Okay, yeah. Now I see your laser point. Good. So do you understand, Kyoko and Inesh, that this value, the y value, is basically your 15/17? No? I'm going very slow here. You have to understand this. If you don't understand, you have to tell me. If this is 28.1, then this guy is your sine 28.1. Hey, sorry, cosine. My goodness, blue is cosine. Cosine, and therefore that is your 15/17. Does this make sense or not? If it doesn't make sense, you have to tell me. Yes, Kyoko?
Yes.
All right. How about you, Ash? We're going fast, but you tell me if you don't understand.
Yeah.
Sure. Now, I will now draw a line horizontally for whatever reason. I am continuously drawing the line. I'm unsatisfied. I am unsatisfied until I meet my cosine graph. Okay, which is actually kind of badly drawn. I'm going to correct it a bit. Kind of badly drawn. Okay, right, that's much better. Now, pray tell Kyoko and Aryan, I did this weird thing, a horizontal line across 15/17. I ignore the 28.1. I go across until I meet the cosine graph again, and I'm very interested at this graph. This guy. Kyoko and Inesh, tell me, what is this angle? Do you know? Is there any way for you to
Take 360 degrees minus 28.1.
I would agree with you totally. This guy is 360 degree going backward minus 28.1 degree. Inesh, do you understand what's going on?
Somewhat, yeah.
All right. So this is from calculator, right? 28.1. And then according to our analysis using the graph, we suddenly think that B may also be 260 degree minus 28.1 degree. Because again, this is 28.1. So this is 28.1, right? Considering the sentence, B is a reflex angle, supposedly 180 to 360, which one is a better choice for B? Which one? The 280.1, 28.1, or the 360 minus 28.1? Which one is a better choice? Kyoko?
28.1.
No, because 28.1, even though the calculator gives you, is not a reflex angle. B is not a reflex angle. So 28.1, even though the calculator is giving us that, is not the most accurate answer. This is going to be confusing to you. The calculator is somehow wrong. Somehow it is. We're trying to understand why is that so. Okay, it is wrong. But notice that I use my 28.1 here and I identify another guy. You know what? Why don't you just do this for me? Okay, you're gonna cosine inverse 15/17 again. Please do that for me, both of you. Cosine inverse 15/17. Do that for me. All right. Now that's all the ugly number, and then I'm gonna say 360 minus answer. Go ahead, 360 minus answer. All right, Michael, I can see you again. Right, also an ugly number. Now you're gonna press sine of that ugly number. So sine answer, please. Okay, so sine answer is now giving you minus 18, correct? Okay, minus 18/7, different from the original sine B. So what does this mean? What does this mean? Let me clarify this very clearly. If I press sine 28.1 degree, I get 8/17. However, if I press sine something different, this 360 minus 28.1 degree, I get minus 18/7. The 8 and the 17 is correct. The minus is not. The minus matters a lot. I'm trying my best to explain why here. This is where your 28.1 from your calculator is simply wrong. It is wrong because it doesn't follow the reflex angle. You cannot just use it. You will be proven wrong, basically. Right? You may not understand why this is fully wrong, but at least you have some sense. That's what I'm hoping for today for now. Right? The 360 minus 28.1 will be the correct answer for B. Right? So, Michael, I see you now. Now you're in, Mike. You're just in, correct?
Yeah.
Michael, today, unless there's an urgent need, we're revising trigonometry. Right? Noah has been doing in the Jamboard, page 2, page 3, and then later on page 4. Right? So, unless there's an urgent need for your topics, I want you to revise trigonometry. Right, for prelim preparation, prelim is like 1.5 months from now. Okay.
Okay.
I'll follow you using video. Now, is there an urgent topic for you?
No.
All right. For Sunday, would you like to have a break because you have to prepare for your O level?
Sure, I suppose.
Right. I'm gonna tell your father so that he knows. Okay. Right.
So what time do we even start on Sunday?
The usual timing. That's considered normal timing. That means that's around like what's the normal timing? 5, is it? 5.
5?
Wait. Yeah, 5 to 6:30. No, 6. I'm sorry, 6 to 7:30. Sorry, 6 to 7. The normal timing. That's the normal. Right. You can join if you want to. I'm just giving you, more freedom because I know you'll be having your mother tongue. Okay.
Okay.
Right. Now for today, we're just revising trigonometry. So go and find it. Now, Kyoko and Ines, sorry about that. So any question on what I'm doing right now? I know it will feel disorienting, but try your best and ask questions if you want to. Okay, Kyoko. Okay, Kyoko. Okay. Oh, Ines, I lose your video. I lost your video. Okay, it's in again. Make it to landscape. All right. Okay, Ines, can you? Okay, Ines, any questions so far?
No.
Right. So I'm gonna erase everything and repeat this one more time. I'm gonna erase everything and repeat this one more time. Oh, I can just create it. Okay, you press your calculator whenever you feel it is appropriate. Okay, you're just seeing me do stuff, so my own working. I see A is obtuse and tangent A is this, right? So if tangent A is -3/4, then what is A according to calculator? Right. Go ahead, Kyoko and Aditya. Michael, don't wait for me, Michael, because you're a Sec 4 student. I'm just giving you time to revise yourself. However, if you cannot, then of course you can follow my explanation. Right. Kyoko and Ainesh, give me the number.
Wait, where are you right now? Which
The new
question?
Jamboard. New Jamboard page
No,
2. I share with you.
which question?
0623 final holiday.
It's the
Page
question
2.
5.
Page 2.
Question 5.
Yeah, question 5. That's correct.
Okay.
However, this is wrong, right? Kyoko and Ainesh, this is wrong. Can you hear me? Is it lagging here? Is it lagging back?
No, no, no.
Okay. Ainesh, is it lagging back? Yeah, Ainesh, you're completely frozen. Ainesh? Ainesh, you're completely frozen. Can you hear me? Ainesh, can you hear me?
Yeah.
Okay, good. Right. So this -36.9 degree is wrong. Kyoko, tell me why.
Because it's not an obtuse angle.
Right, which is by definition from 90 to 180. However, Kyoko and Ainesh, even though this is wrong, this is still useful. This is the weird thing. I'm going to show you why. Right. I'm going to show why by using the drawing. Right. So I'm going to draw very quickly here. Right. I'm going to draw a tangent graph. You have never seen a tangent graph before, Ainesh? Let me confirm that.
Yeah, no, I haven't.
And this is the, oh, yeah, which is very good. So like,
No, I haven't.
all right. So just follow me first. This is a tangent graph. You believe me for now. Huh? Now, pray tell, Ainesh, where is -36.9 degree in this graph? Where is it? Where is it? Very good, right? So weirdly, it's behind. So this is your -90. So your -36.9 will be here. And Kyoko, is there any graph behind here? Have or not? No, there is. There is. Every trigonometry graph is always infinitely repeating. You understand? It is always infinitely repeating. So there you go. I just draw that for us. Now, this is part of my explanation why I'm telling you the calculator is giving you 36.9 because this guy is -3/4. It doesn't look like it, but that's your -3/4. Okay, that's your -3/4. Now, where is quadrant 2? Quadrant 2 is here. There's your quadrant 2. -3/4 has another guy here. There is another guy here. Right? So Kyoko, please tell me who is this other guy? Who is that guy? Right? It's not -36.9, but -36.9 is like that from 0. So from 180 to this. So who is this guy?
143.1.
Correct. So that would be, I would just say 180 -36.9. Can yeah? Make sense, yeah? So A turns out to be 180 -36.9. Now this is correct. Do you see that it is now an obtuse angle? Ken, Kyoko, and Ainesh, it is now an obtuse angle. Can yeah? So using this new value, not the calculator one, using this new value, you're going to tell me what is 1 over cosine A. Please tell me what is 1 over cosine. Because there is what second. Right, Kyoko, the reason why they don't give you a nice number, do you know why he is not giving you a nice number? Do you know why, Kyoko? He's not. He is not giving you a nice number, but we really need a nice number here. Why is that so, Kyoko? Just now we get nice numbers, you know. Do you know why? Because you round off the number. You don't preserve the answer. Remember, the answer is not 36.9, but a round off. In your calculator, don't use 36.9. You have to use the full answer, the ugly, super long decimal answer. Same thing with you, Ainesh. You cannot use this number. You cannot use this number. You must use the full answer from the original. Do you understand what I'm saying, Ainesh? Do you understand what I'm saying, Ainesh? Tell me.
Yeah.
Right? So both of you, you have to tangent inverse minus 3 over 4 again, so that you get the long answer, and then you have to preserve that answer. Then you will get a better answer if you use that. So Kyoko, did you actually get a better answer this time? Very good, right? In fraction, there will be my 5 over 4, right? Wait a minute. No. Come on. It should be minus 5 over 4. Wait, Kyoko, what's going on? It should be minus 5 over 4. Ainesh, do you want me to guide you?
Yeah.
Ainesh? All right, follow me. Tangent inverse minus 3 over 4.
That's why.
Okay. So you got it in the answer, yeah? Tangent inverse minus 3 over 4.
Yeah.
And then 180 minus answer. That will preserve the long decimal. 180 minus answer. Right? And then you cosine the answer first. You cosine the answer first.
Cosine tangent minus 3 over 4.
No, cosine 180 minus tangent inverse minus 3 over 4 if you really want to do that. All right, Kyoko, you get the minus. Okay, because Ainesh, I cannot follow your calculator, so you do it step by step first.
Yes,
Just follow me. Right? I cannot follow it. So what answer do you get? Because I cannot see, it's super blurry. That's the reason why. So what is the answer for 1 over cosine? I cannot hear you. Very, very, very laggy. Maybe you can tell me, right, or write down something.
Jesus Christ.
Super laggy, super cut off. Very difficult.
Okay, I'll hotspot.
Okay, please do. Please do. Michael, are you stuck with the first question? Because I cannot follow. I can only see your top working.
No.
All right. Just to remind you that this is not your method. Your method is easier than this is the triangle method. You're supposed to use the triangle method. Just to remind you for this question. The triangle
method.
You have no idea what I mean by the triangle method? Like this thing? No. The usual method that the teachers use.
This.
And the triangle. That this is not what you do normally? No? Oh. This is A, and this is like this is 3, and this is -4, and this is 5. No, you don't usually do this triangle.
I mean, recently, no.
Okay, you do what you do, but I'm a bit surprised on that. You do what you do. If you can do it, I have no concerns lah. But if you cannot, you better revise your triangle.
Why was the bottom line -4? And not like the other line is -3.
Because y-axis, x-axis move to the left is minus.
Oh yeah.
But y-axis move up is positive, yes? Okay, right, okay. All right, good, yeah, okay, great. Okay, Ainesh, I can see that you're back. Still a bit blurry, but maybe our audio is better. Can you hear me?
Yeah, can you hear me?
Okay, better. So I won't be seeing your video for now. Just tell me what's the answer for your calculator.
I lost it. My calculator turned off.
Okay, again, quickly, yeah. So do it again, but tell me what's the answer. So I know it's right or wrong.
It's a tangent -3/4 then.
Tangent inverse -3/4, you'll get a long answer.
Yeah.
And then 180 minus that answer. Okay,
Yeah.
and then cosine of that answer.
Okay.
What is the answer?
-4/5.
Okay, so 1 over cosine, because that's what secant means. That's just what it means. 1 over cosine, I will get -5/4. Make sense?
Yeah.
All right. So -5/4 is not what you get when you use this law. You will get 5/4. And that's why this answer is misleading, even though it is useful. Misleading, though it is useful. Okay, that's the minus difference. Okay, we're gonna do the second part, and then I'm gonna show you another variation. Ainesh, read for me the formula from the first page. The formula from the first page, sine A plus B. Read for me.
Sine
A plus B from the first page. Sine A plus B equals to, yeah, it's called sine A cosine B plus cosine A sine B. I'm just shooting a shortcut. So read for me.
Sine A cosine B plus cosine A sine B.
Good. Where does this come from? Well, it is provided for us, right? Now, look at what we now. What do we have? Do we have sine A? Do we have sine A? Yoko, do we have sine A?
There you go. It's not blurry anymore.
You have the angle. You have the angle A, yes. But do we have sine A? We don't, yeah? So that's a question. Do we have cosine B?
Yes.
Yes, 15/17. Ainesh plus, do we have cosine A?
Yes.
Which is, what is cosine A?
We do.
I cannot hear you. What is cosine A?
We do.
Yeah, it's -4/5, right? Remember just now? Right? -4/5. We have it, right? We have it just now.
Is it
Okay.
5/4?
I'm sorry, I cannot hear you clearly. Yes.
Is it -5/4?
-5/4 is secant A. Secant A is the 1 over cosine A. 1 over cosine A is -5/4. So cosine A is -4/5. Does that make sense?
Okay. Yeah.
Clear, yeah? Now, do we have sine A? Do we have sine A? Oh, sorry, sine B. This is supposed to be sine B. I'm so sorry. Sine B. Do we have sine B? Do we have sine? We don't have. So we're supposed to find sine A and sine B, and then 2 marks is ours. I think sine A is easier. Could you please kindly find sine A first, Ainesh and Kyoko, and tell me what's the result? So Noah, I see that you have done the second question, right?
Yeah.
Your drawing seems X. Whoa. Wait.
I don't know how to draw tangent graph.
Oh, your tangent graph is a little bit troublesome. So I'm going to draw for you this. So I think your tangent graph is a bit misleading. 1, 2, 3, 4, 360. I am currently drawing the tangent graph only, not the tangent x/2. So just to remind you. Right, -2. Right, good. That is correct. Good. Ainesh, did you get the same answer? -3/5? If not, please tell me.
I got 3 by 5. No, I got minus 3 by 5.
So very interestingly, both of you are wrong. Sign of this is supposed to be positive. Oh, somehow both of you are wrong. Please try again. Somehow both of you are wrong. That's the tangent graph, yeah. Noah, in page 3, yes.
Okay.
So now, what happens when you x over? What happens? Very simple, right? You have to change everything to times 2, correct? This will be your 180, this will be your 360, this will be your 540, and this will be your 720, correct? That's what it means.
Oh,
Do you see your error?
okay.
So
Yeah.
it's half right, half wrong.
Got.
Yes, Michael? Yes, Michael?
So, is this B is a reflex angle?
Because it means it's from 180 to 360,
Yeah.
quadrant 3 or quadrant 4.
How do I do that?
There is only, because this is quadrant 3 or quadrant 4, that gives you some problem, right? But they tell you cosine B is positive 15 over 7. That tells you which quadrant.
Yeah, it's quadrant 4.
All right. Minus 15, minus 15 downward lah. I'm so sorry. No. 15, 17. 15 to the right lah. Quadrant 4, 15 to the right and then 17 down, no? Right?
Yeah, I got 3 by 5. It's 3 by 5.
Correct. It's positive, not negative, right?
Yeah,
So, right. So, Kyoko, did you finally get positive or are you confused here? Positive, yeah? So it's not negative, yeah? I am guessing that you guys didn't use this value, but you use that value lah. That's what I'm guessing lah, right? That's what I'm guessing. So be careful there. Be careful. The calculator is misleading. It is.
But I didn't.
Sorry, Anesh?
All I
Sorry?
did was this, like, this multiply.
I'm trying to follow your laser pointer. I'm so sorry. Yeah, I cannot seem to do that. Oh, minus 4 over 5?
Yeah, that multiplied by this.
That is only correct. Your sine of well, you can do that. I'm so sorry. You can. Why do you multiply? Let me think for.
Because
Oh yeah, it is. If you multiply that, you will still get positive. I agree with you. I totally agree with you. So why did you get negative in the first time?
I don't know actually. It might have been like a typing error or something.
Be careful, eh? Be careful,
Yeah.
Minus, no mercy one. No mercy, yeah. No mercy. There is no mercy at all with minus and pluses here, right? They're aiming for something important and that they can tell whether you don't understand it. They can tell. Yeah, no mercy. Now, slightly harder challenge for you. So please tell me what is sine B. You have your cosine B, you have your reflex angle. Please, both of you find sine B. Let's see whether you're correct. Now, Michael, your triangle for the 15 and 17, okay? Yeah, it looks correct. Right? So what is your sine B?
Sine B is
That's what you need,
over
I'm guessing. Very good. Minus 8 over 17. Good. That's it. So Ainesh, Kyoko, find your sine B lah. What is it?
No, we don't have 10B, right?
No, you have cosine B on. You have cosine B on.
Then how?
Then you may want to consider the method I showed you just now lah. You have to go through the whole method lah, I suppose. Right?
I mean, I didn't fully understand your method.
Right? I'm going to do it manually. Cosine B, follow me quickly. From 180 degree to 360 degree. So this is my caution. So first, I'm doing the illegal method. I'm doing this illegal method to help you understand. So B will be cosine inverse, right? Tell me, what is it?
Is it 5/17?
I'm sorry, 17, right? So cosine inverse that, please. Keep the answer, yeah?
28.07.
Right?
Yeah,
Yeah. So this is wrong. Tell me why it is wrong.
because it's not a reflex angle.
Not reflex. Again, what is going on with this calculator, right? The calculator is messing with us, right? This is part of my lesson to you. Like, it is messing with you guys, but not intentionally. Yeah, you will understand that later. So I have to find the proper below. How do I do that? The method I show you is I use the graph first, lah. Right? So I use the graph. I do it very quickly. Sorry. And then I realize this is 28.1, correct? This is my 15 over 17, correct? 28.1. And then I track back until I meet the cosine again, and I realize this might be the correct answer. Who is this guy? So B actually should be, what is this guy? Again, you, very good, Kyoko. You did a 360 minus 28.1, right?
Oh.
So this should be correct because, hey, wait, that's also reflex. That's between 180 to this. Okay, I did something correct, right? So you're going to do 360 minus your answer, right? 360
But
minus your
why?
answer.
I don't get it.
Quickly do it first, Anish. Quickly do it first, and then I'll explain after this. This is the point. This is what I'm supposed to explain to you.
61.9.
Minus 8, right? So you have that, and then you're gonna stop truncating your answer, Anish. You're preserving your answer just now. If you don't preserve your answer, you will not get the nice answer at the behind one. Stop truncating your answer. I know I'm writing it 28.1 because I cannot write the full answer, man. Stop truncating your answer. Stop. Right, this one, use this one minus answer. Okay, and then whatever this number is, and then you will need to sign that number up. Then you have your minus 8 over 70, right? Let me underscore this one more time. If you directly sign 28.1 or that number, you will not get minus 8 over 70. You will get positive. This is your calculator messing with you. Okay? So I'm telling you that your calculator is dangerous, or rather is limited if you do not know how to use it well. Definitely one. This is my proper warning to you, in the sense that calculator should be your servant, not you depend on your calculator like they are smarter than you. No, you need to be smarter than your calculator. This is really the moral message here, really. Yeah. If you keep depending on your calculator but you are not smart, it will seem that your calculator is misleading. It will seem like that. Now your question, Inish, is a desire to be smarter than your calculator. Let me explain. Okay. This is your cosine graph, yes? Now, do you understand this? Let's say this is 30, easier, yeah? Ting, ting. Now, see, I start from angle and I go find this number. This number will be half root 3. Okay, I'm referring to your special table. Do you understand what I just did, Kyoko and Inish?
Yes.
Okay, how about you, Inish? If you don't understand this part, you must help.
Yeah, I understand.
All right, so this arrow is a process of cosining the 30-degree. That's what it means. Okay, cosining the 30-degree will give me half root 3 according to the table. Now, what is the name of the process of the reverse? Like that, that's the reverse. What is the reverse of going from half root 3 to 30? What's that process called, Kyoko and Inish? What's that process called? The blue one is cosining the 30-degree. I will get half root 3. The red one, keeping it simplest, is obviously cosine inverse half root 3. You get your 30-degree. That's the process. Look. Now, does this make sense?
Yeah.
So it's just a reverse, like the way cosine inverse is a reverse of cosine. Obviously, in the graph, you just go back and forth. Actually, it's very clear in the graph. So one more time, if I go from angle to the y-axis, so from the x-axis to the y-axis, is that cosine or cosine inverse? Kyoko and Arya?
Cosine inverse.
No. From x-axis, I want to get y-axis. Cosine or cosine inverse?
Cosine.
Cosine. Because see, cosine 30, 1 half root 3, right? If I want to go from y-axis to x-axis, I can definitely do that. Is that called cosine or cosine inverse, Ainesh? Cosine inverse. Is this clear first or not? That's what it means graphically. What you press in your calculator has a meaning graphically, is what I'm trying to say. Clear?
Yes.
So let me show you something. That's why, for example, look, I'm going to put this 120 degree. Ding dong. This guy is cosine 120, look, correct? Make sense? Cosine 120. I'm going to predict, if you press your calculator, it's going to give you a half. It's going to give you a minus number. Because the graph tells me so. Oh, it's going to give me a minus number. Please try cosine 120 minus. See, minus half. The graph predicts what the calculator will give us. In some sense, like it's going to give us a negative one. Look, the graph predicts. The graph is actually better than calculator in some ways. Do you understand your point, Anish?
Yeah.
Now, back to the problem that we have. How come the calculator is like fooling us? It's very simple. The calculator is fooling us because like this. Because in the initial stage, we went inverse. So for example, I want to inverse my 15 over 17. The problem with inverse is you have more than one answer. If I want to inverse from half root 3, my answer can be 30, can also be this guy. This guy is called 360 minus 30. The process of inverse gives you multiple answers by right according to the graph. That's the whole problem. That's what they want you to learn. This will sound so weird. Do you somehow understand a little bit, maybe?
Yeah.
That's how. The inverse process, if you rely on your calculator only, will always fool you somehow because you're supposed to consider one of the multiple answers. That's the danger of inverse process in your calculator. That is the danger. The reason is because the shape of the graph allows many answers if you go from y-axis to x-axis. That is the reason why. If you understand this, you're saying to the examiner, okay, I get my trigonometry graph. I get it. If you don't understand this, you will be confused until the end. So we're starting early here. Ainesh, that was my explanation to you, to your answer directly. Do you kind of maybe understand? Kind of. And we're going to repeat this all the time because this is the basics of trigonometric math, the thing that they want you to understand. Okay? All right?
Yeah.
Right. Now you guys rest for a while. This is a lot, yeah? Rest for a while. Okay, just rest for 2 or 3 minutes, and then I'm going to introduce you some other thing. All right. Now, Noah, tell me where you are. How are you?
I finished the thing.
You finished question page 2, page 3, and page 4.
Yeah.
Most excellent. Right. I'm going to check whether the answer is correct first, which is by copying. Michael, how are you? Can I copy?
Stuck on page 3.
Oh, page 3. So let me copy. Okay, I've copied your answer, Noah. Do you have the answer for the page 4.1, the question 1? Oh, you have it. Okay, understood. Right. Okay. Just a minute. Huh? Noah, tell me a topic that you really need to revise. I'm happy with trigonometry for now. Logarithm, index, discriminant, polynomial, binomial.
I think it's like integration and differentiation, but what problems?
Still like what problem? What do you mean by what problems for calculus? What do you mean by that?
They tell me a story and I'm supposed to find what they are asking.
Usually that's only kinematics. Is that what you say?
Oh, no.
There isn't a lot of story one in differentiation integration, not in O-level, not in O-level. Are you sure?
Oh no, never mind.
Nothing else you need to practice, really?
Well, I have some questions.
You want to practice yourself? I'll follow.
Some questions to ask.
Oh, please put them. So I'm going to help Michael in the meantime. So Michael, you'll start at page 3, right?
Yeah.
Right. So,
I'll look at it for a while.
of course. Let me remind you how to draw GX. Huh? Do you still remember how to draw GX, Michael?
So the 5
Start
at
for
the
sine.
back is the sign is the you start at the origin, then you go up.
Then you have to adjust, right? You have to adjust. This will be your -2, this will be your 3, and this will be your -7, correct? Going
Yeah.
very quick because 5. Okay. Then you're almost done, no? And this is going to be your 360 because it's normal. Okay.
Yeah.
Done. Now, just like that, you can already state the least and greatest value. You done 3 and -7, correct?
Yeah.
And then the period of fx will be, because of the half, the period will be 720, because it's 360 over half. By the drawing, you can see that also, but that's basically it. 360 divided by half, 720. Can?
The drawing. Oh, okay. Yeah.
The problem is because maybe you don't draw tangent x over 2 a lot. That is a usual problem, and you need to revise that. Now, state period of gx. What's the period of gx?
The period of gx is.
You are very confused about the period of gx.
Yeah.
It's
wait,
360. It's 360.
Yeah,
it's 360. It's normal. It's normal.
Yeah.
All right. Now, looking at the drawing of fx, I draw for you a tangent graph, right? Correct?
Yeah.
The tangent graph is supposed to be 90, 180, 270, 360, normal, correct? Tangent graph.
Yeah.
But I'm not drawing tangent graph, I'm drawing tangent x over 2. Because of the over 2, everything must times 2, right? 90 becomes 180, blah, 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 blah. Correct?
Okay.
Make sense? Make sense or not? Wait, make sense or not?
Yeah. So no, the only reason why tangent x is like instead of 90, 180, 270, instead it's like double, because it's x over 2.
Over 2. Yeah.
But for the case of sine, it's 5 sine x minus 2. Let's just say the 5 isn't there. Then sine x minus 2 is just the amplitude. 5 is the amplitude, like the normal amplitude, and then the x minus 2 is like the amplitude.
The shift, you call it the shift, right? The shift, right? Correct. Correct. The shift. Right? And the x, since it's just an x, the period is untouchable. Makes it a bit easier for us.
Yeah.
And then you're supposed to combine, right? You're supposed to run for 4 marks. You're supposed to combine this drawing and that drawing.
Okay.
That's the big number. Actually, that is the big number. That's why we always start with the drawing. Never mind this small number. The small marks are very easy to do. If you have the drawing, then you're just guessing. Okay.
Okay. Yeah.
Right. So you try. You need to practice your drawing skill, by the way, you need to, by the way. Your drawing skill not so good. So you need to practice it right now. And that'll benefit you.
Okay.
Okay, Ainesh and Kyoko. Are you back?
Yep.
Right. I'm going to practice a similar question for this one, right? Similar question. So I'm going to give you that question. Apologies, I'm sorry. I have a difficulty in. Oh, okay, yeah, that's why. Oh, there you go. Right. Okay, I'm getting the question for you. Oh my goodness, right, sorry. Right, okay, that's bad. Okay, that's bad. That's really bad. Wait, sorry. You know what? This one is the easiest one to make, right? So in page 3, we're going to make a question, right? So Ainesh, give me a random fraction, please, but a proper one.
What do you mean? Proper?
That means not more than one proper fraction. Not more than. Yes, Ainesh?
3/4.
3, oh, too easy.
4/7.
Right, fair enough. I'm going to put this as either sine or cosine or tangent. So, Kyoko, tell me, will this be a sine, a cosine, or a tangent?
Cosine.
All right, cosine A. Lastly, from our question maker perspective, right? We're not a question maker. Lastly, do you notice that cosine A will be positive on quadrant 1 and quadrant 4? Do you understand what I'm saying, Kyoko and Ainesh? Do you understand what I'm saying? Cosine A, 4/7, right?
Yes,
so
yes.
4/7 will indicate, that means 4/7 will indicate something like this, 4/7, right? Because that's the y-axis, will indicate that actually the answer can be here, or the answer can be here also for A. That's what it means. Quadrant 1 or quadrant 4. They actually add these two options already. This is what we're learning today. Do you understand, Kyoko and Ainesh?
Yes.
So, to make your life difficult, you must not say that this is an acute angle. That's what the question will not do for you. The question will not say there's an acute angle. The question will say this is a reflex angle to make your life difficult, because this is going to be easy and this is not going to be, well, as easy as it is. That's how the question maker, I suppose, process his or her question for you. Okay. Remember, acute means from 0 to 90. You'll be referring to this guy, and this guy is always easy. This guy, it is not. Okay, so here's the simple challenge. Find sine A and find tangent A. Simple challenge. Will it be plus or minus? Will it be plus or minus? That would be the challenge for both of you, Kyoko and Ainesh. Give it a try. Okay. This one, work it out, and refer to page 2. This is exactly what happened in page 2, by the way, just saying. Exactly what happened. Nothing different. Okay. So, Michael, are you saying that you're going to draw the tangent and the sine graph separately first, then combine? Is that what you're saying here?
Just to be sure, if it's the inverse, the whole graph thing, right? For tan, it's 180 minus whatever, and then for cosine and sine.
You're probably memorizing it too much. The 180 minus. No, I never say that will work for every graph. I never say that. I'm saying that that's the result of me analyzing the graph. Oh, that is 180 minus. Sometimes it's 360 minus. Sometimes.
How do you know? How do you know it's 180 or 360?
Look at the graph. For example, your calculator will give you this number, right? I'll call this number, I don't know, whatever, 52 degree. Let's pretend. Let's pretend that there is 52 degree. Your calculator will give you, okay? But your calculator is lying to you because it's not reflex, okay? So it must be this guy according to the cosine graph. Oh, if it is going to be this guy, then clearly it is going to be 360 minus 52. At least when I see the graph, I'm analyzing the graph here. I'm not memorizing anything, by the way. Do you understand what I'm saying? I'm doing things in page 3.
No, I don't understand.
One more time. The calculator will give you this guy. That part, do you understand, person?
Yes.
Then the graph tells me, wait a minute. Cosine inverse has always give me, or rather has always been a lot of option 1. In this case, there's 2 options presented to me. This guy and this guy. That one clear? If that part is not clear, you tell.
No, I'm good. Yeah.
Sorry, yes or no? Sorry, clear or not clear?
Yeah, I understand.
Okay, then the last thing, oh, is this guy and that guy? Yeah. Okay, wait. I think I know who this guy is. That's what I'm saying. I think this guy is 360 minus 8. That's what I'm saying. Now that part, do you understand?
No, this is where I get lost. How do you know it's 360
Very
or
simple.
180?
Very simple. Very simple. Now that's the part where I have to explain to you. I'm using my visual sense. Yeah. So you notice that this is a mirror image of that. Do you notice that?
Yeah.
So that means like this 52, right? Like this 52, correct or not? 52.
Yeah.
So this is 52 also, mirror image, man.
Yeah.
52. So who is this guy? Oh, it's from 360 to the left minus 52, for example. This guy must be 360 minus 52, for example.
Because if it's 180, the graph would be different.
Well,
Like
180 is here, you know.
bigger.
180 is here, you know, right? 180 degrees is here, correct? How does 180 help me in finding this guy? Wait, it's too far. I don't want. 180 is not helping me find this guy. By the way, 180 minus a is this guy, you know, if you agree. That's 180 minus a. Wait. Who is that guy? That guy is not this guy, for example.
Yeah.
Right? I'm not telling you to memorize the 180 minus. That's if I'm asking you to memorize something, I'll make it very clear. I never asked. Okay.
Yeah.
So looking at your number, Kyoko, again, my problem is that it's not a nice number. If it could only be a nice fraction, that would be perfect, no? If it could be, but it is not, right? It is not, correct? So that's the issue right now. However, your minus sign is correct, Kyoko. Your minus sign is correct. Now, Ainesh, can you do it? I do expect to see some working here because I'm guiding you through the end already. Very detailed.
Yeah, I got the same answer.
Right. So it's not a very nice answer. No? That's the other thing about the calculator method. So the calculator fools you. It doesn't tell you the whole story, and it doesn't guarantee you a nice number when the question asks for it. So the calculator is just unreliable for certain types of question, is what I'm trying to say. Okay?
Yeah.
That's what I'm trying to say. But at least you get the minus correct, look. Your sine is minus, your tangent is minus. So you press this, your tangent will also be minus. Okay? All right? Now, we don't have much time to teach you the method which totally skips over the calculator. There is a method to do that. And that method is usually superior in this kind of question. That is usually what the teacher will tell you. Why do I go through all the trouble of showing you the calculator method? Do you know why? We wasted 1.5 hours showing you the failings of your calculator. Why would I do that? Why would I do it? Because we have a lot of time. Because time is, because we are ahead, so we can afford to waste time. Is that why I'm doing all this to you?
No.
And why am I doing this to you, Anesh? Because I think you're a foolish person and I can make you go round and round. Or maybe I'm a bit, I'm trying to torture you. I'm just trying to confuse you with all these new things so that you think I'm smart. Why am I doing this?
I don't know.
Kyoko, any opinion?
Because during exam, this kind of question might come up.
Oh, it will. No, it will come out loud. Yes, correct. But why am I showing you the calculator method, which is again unreliable, failure, not nice, confusing? Why? And let me remind you, it's also not acceptable in exam. It's also not, the calculator method is totally not acceptable at all. They won't give you marks if you do this method one in this kind of question. They won't. Why am I in your 1.5 hour time? Any idea?
So you can do the question in another method.
Why don't I just show you that method? Why don't I just do that? I'm supposed to do that in the second session. I'm supposed to do that. Why don't I?
Because if we didn't know the method, then we will still use the calculator.
Because for some reason, I would probably agree with you, Kyoko. Calculator is just what we do when we don't know what to do, like in exam. Correct or not? We will just fall back to calculator. So I'm saying from the start, for this question, calculator sucks. Calculator sucks. The nice answer you get just now, Kyoko, in the previous question is totally lucky one. Usually they give you this ugly number. Usually. The superior method, the one that skips calculator, will not give you such an ugly number. So there's some superiority in there. So I'm trying to show you the failure of the calculator in certain situation right from the start, so that you will remember that. That is what we do for this 1.5 hours. Okay, your question again? That be okay?
Yeah.
Right. We'll talk about the superior method. It'll take some time, but hopefully you'll appreciate it later. I'll see you later. Okay.
All right.
Okay, Noah and Mike, don't stop here first. So Noah, give me your question. Mike, are you stuck? Mike, are you stuck?
I don't think so.
Oh, you're... Yes. I'll see you in 5:30. Yeah, I mentioned.
Okay, sure. Bye.
Bye-bye.
Bye. So your drawing is fine, Michael. I'm happy with it. So you got your pitch, your second calculation. Can you do the last question?
I have to see first. I'm still looking at it. That's why. But
correct.
So far it's
you will understand that you require identities here.
yeah, I have a trick list pulled up, so yeah.
Good. I am not saying that you should do part 1 first. Part 1 is always the worst thing.
Oh, okay.
I think you should always do part 2, even in exam. Like really do that. Like get in the habit. Part 2 first. Don't whack part 1. Who cares about part 1? Bye, part 1.
Oh, okay.
Really, bye. And it's not your strength. I've never seen part 1 as your strength. Totally fine. Peaceful. If you cannot do part 2, I'll be very, very angry. I'll try to part 2. Okay, yes, Noah. So this thing, the decreasing thing, I think I understand. I agree with your formula. Yeah, I agree with the formula. Okay, so there's a problem with your dA/dt. There is, at this stage, I would say this is not what I expect from you. You have a lot of experience already. Your dA/dt equals to 24 is very problematic. I don't like this mistake. You should know better. I'm telling you a lot of hints. Please tell me what is the mistake.
I don't know.
Okay, read the question. This is not what I expect. Yeah, read the question from the start. The surface area.
Yeah.
Read.
The surface area of a spherical balloon is decreasing at the rate of 24 cm squared per second.
You didn't get the hint.
Am I supposed to use a formula of say?
No. Your mistake is simpler than that, and that's what frustrates me. Your A equals to 4 pi r squared is excellent. I like it. That means you read the fact that it's a spherical balloon. I like it. You know that they are giving you dA/dt. That's what is frustrating to me. You didn't even see the mistake. I don't like it. Actually, I don't like it a lot. You're basically saying, okay. So you must understand this mistake is something that you have to understand today, right now, and then don't make it anymore because you have an additional understanding. Look, you're saying that the dA/dt is positive 24. You still don't get it.
Is it because it's decreasing?
If it is decreasing, can you say that your gradient is positive? Does that even make sense? It should be
negative.
Correct. There is a meaning to the positive and the negative. Do you understand or not?
Okay.
So one more time, dA/dt can be negative, even radius cannot. Obviously, radius cannot be negative, right?
Yeah.
But dr/dt can be negative. Do you understand or not?
Yeah.
Why is dr/dt negative? How come that makes sense?
Okay, so is it? Oh, okay.
Because your dA/dt is negative, it will affect your dr/dt, correct?
Yeah.
Your dr/dt become negative. That makes a lot of sense here. Why?
Because it's decreasing.
Correct. It's getting smaller what? So if the surface area is getting smaller, that means the balloon is, leaking. That means your radius should also be decreasing.
Okay.
That makes sense, right? Your answer, which is positive, becomes wrong no, because of that. That's why. No. Okay. Michael, are you doing the second part or the first part? Sorry.
The second part.
Okay, move up first because I cannot follow what your writing is. Oh, you're doing the second. Wait, where's your second part? Sorry, where's your second part?
This is the second part.
That's not the first part, right? Would you mind telling me why you use why do you bother with cosecant x? Sorry, I don't get it. Why are you bothering with cosecant x in part 2?
Oh, because it's cosecant x 2x in part 2.
Oh my goodness, you're very rusty, isn't it? You're so rusty that you don't understand the question. I expect more from you, considering your experience. There is a show, right, on top, and then there's a hands, right? This is just the normal thing that happens, right?
Yeah.
You didn't use hands, like you totally do not use hands at all. You just don't. What's going on here? Are you forgetting the logic of this question? Like they ask you to show because they want to make your life easier. Put it another way, you cannot solve part 2 without part 1. You just cannot. You're going round and round, wasting time. You're supposed to use it. Can you? Right. So Noah, other than that, I think your answer is right. They didn't give you radius, no, they don't. Oh, they do that below. So it's done. Very happy.
So part 2, what do I do?
So the rate of decrease when the radius, first of all, you put the R as 10, right?
Yeah.
Secondly, so that you're not confused, you're not supposed to put in the minus in the final answer. So the first part, your rate of change should be negative. The negative is the meaning decrease, correct? Decrease. Yeah. Then you see part 2. Part 2, they ask you for decrease. You should be quite happy. Oh, that means I'm correct in part 1. Understand?
Oh, okay.
But your final answer should not include the minus because they already asked you for the decrease. Oh, the decrease is 3 over pi 10. You are decreasing at the rate of 3 over pi 10. You cannot say you are decreasing at the rate of minus 3 over pi 10. Does that make sense?
No.
Okay. The first part is they ask you for the rate of change.
Yeah.
That's a very neutral statement. Neutral statement means the rate of change can be increasing or decreasing.
Yeah.
So the minus must be there. If not, you're wrong. But for part 2, look at the original sentence in part 1. The surface of the spherical balloon is decreasing at a rate of 24. He never say it is decreasing at the rate of minus 24. He never say that.
Yeah.
But when you write the ADT, you must write minus 24.
Okay.
When you put it in English, you must not put the minus because you already say the word decreasing. Decreasing actually means minus.
Yeah.
So when your second part, when your answer is decreasing is minus 3 pi 10, you're basically saying minus minus. That's the problem.
Okay. So
do you understand?
Yeah.
Yeah. So do you just?
But do I just add substitute R equals 10 or what do I do? What else do I
Oh, that was this decimal, and you must remove the minus and then you're done.
But it's 3 marks.
Oh, I'm so sorry. It's the volume. I'm so sorry. I didn't read the volume. Right. So what you get from here is the RDT, right? The RDT is minus that. So you have to go back to and find the DVDT. That means you need the VVR, sorry, DVDR. Yeah, and then you have to find the volume and everything. Sorry, I didn't see the volume. My mistake.
Okay, can.
Right, so please give it a try. Michael, are you stuck? Yes?
Are they asking DVDT or DVDR? DVDR.
No, because they ask rate. When they say rate, they mean what?
Time.
DVDT, but you need DVDR.
Yeah.
Is that weird? No, right? That's not weird, right?
No, it's not.
Okay, go ahead, try. Then you can stop. Michael, are you stuck? Wow, you're super rusty, isn't it, Michael? You're stuck here.
Yeah.
Oh my goodness. Yes. Oh, I don't like. Oh my goodness. No, 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 no. What are you? Oh my goodness. Right. Just follow me and then we're gonna end. Wow, you're very rusty. Wow. Wow, 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 wow. Are you clear with this?
Yeah.
Right? Am I supposed to cancel this? Am I supposed to cancel it?
No.
No, why not? Tell me why not? You don't know why.
Because then we won't have all the answers.
Very good. You lose answer. Now then I teach you the completeness. You're not supposed to cancel because you lose answer. Then I remind you very carefully, what are you supposed to do when you cannot cancel? I tell you it, I tell that specifically. So don't cancel. And yet do something else. Do you remember?
Sorry, no.
Factorize. Remember that for me right now. Don't cancel, but factorize. This is what I teach you. I don't just teach you don't cancel. What do I mean by factorize? What are you supposed to do?
Cosine x times 1 over sine x.
I'm just going to show it to you. Oh, you're so rusty. I don't believe it. Now, the reason why I put it on the left-hand side is simply because I can factorize. What else there is? I'm supposed to factorize, like that. Right?
Okay.
When I factorize, then I'm safe. Because then I won't lose answer. Now, can you continue from here? If you can, then you just do it, and then we'll see you in 5:30. My goodness, you're very rusty.
Okay, yeah. Wait, so do I do this right now?
Yes, please, because this is not difficult now. What do you do after factorize? No, I'll move up, please.
I can find each and every individual one. So
yeah, please do. Right. So DVDR, very nice, and then you very nice. Yeah, very nice. Okay, let's stop here for. The rate of decrease, the DRDT, which is positive, is not useful here. That's me saying things wrongly because I thought they asked you for the rate of decrease of the radius. That's my mistake. You don't have to write that down. That's useless.
So
You're supposed to stick with DRDT equals to minus 3 pi.
okay.
Yeah. That's me misleading you because I didn't read the question. My bad. Yeah, it's still supposed to be minus, in the working math rules, right? And then you understand the math. The English is the one that is confusing. Very good. So remember, your final answer is supposed to be what? So now we are back to English.
Okay.
Now English. No, it's okay. Don't erase anything here, but you must say rate of decrease equals to 120. English problem. Math correct. English is annoying in math lah, at least. Okay, so Mike, I'm seeing 0. Okay, I have a problem with you, Mike. Like really, you're rusty. You're supposed to remember that when you do the inverse, you're supposed to get at least 2 answers. However, you stop short of giving me more than 2 answers. So the x equals to cosine minus 0 supposedly give me 2 answers. Why are you giving me only 1? Is there a good reason for that?
okay. Pi is 3.14.
Correct, 180. Correct. Yes, 180 lah. That's 180. I think it's easier to do 180. So are you supposed to give me more than 1 answer or not for the 0?
No.
Because?
I can, but it'll be just 1.57.
No, the other answer is 2 pi minus 360 minus that.
But then this thing is within 180.
You are correct. You're correct. Then my question is the second guy, lo. The second guy is supposed to give me 1 or not? 1 or 2?
It's 2.
Yeah. You forget
So
something.
It's 3.14. So it's pi minus 0.524.
Yes. Okay. If you write that down, happy or no? You missed that, still, you missed that. So your rustiness, you must get rid of it, right? Okay. Any other question? No.
Oh no.
All right. Oh, that's your question. Oh, that's not bad. I will see you later. We'll practice more. Right? We'll
Okay,
practice more.
yeah.
All right.
See you.
Bye. Okay, Michael, clear?
Yeah.
You're gonna have to repeat because you're rusty. As in later on for the same type of question. Okay.
Okay.
All right. See you, Michael. Bye.
Bye.